Voice is lagging. Just a minute. Now it's okay. Okay. The things which you have to consider is the force, amount of force which is applying on it. Okay, and the point where we have to take the moment. Okay, and the point where we have to take the moment. Okay, and the third thing is perpendicular distance. Take this thing. Okay, the main things are, again, just repeat it, the force which is applying on it, the force which is applying, and the moment. Okay, second thing, moment where we have to take the moment. Okay, it's maybe moment, yeah, the point maybe at here, maybe at here. Take either maybe at here or maybe at here. Okay, it's maybe anywhere. Okay? But we have to consider the point where we have to take the moment. And the third thing is perpendicular distance. Okay, as well as the next thing is clockwise or anti-clockwise. Okay, okay, is it okay? Huh. The point, the first thing, the point where we have to count the moment. Second thing, force, which is applying. Okay. Third thing, third thing is perpendicular distance. Perpendicular distance. Okay. And the fourth thing is a clockwise or anti-clockwise. Clockwise or anti-clockwise. Just see. The point is at here. The point is at here. And the force is applying at, and the force is at here. Okay, and the moment which is applying on it will take the round like this. Okay, it is like clockwise. Okay, it is clockwise. Okay, suppose the point is at here. Suppose the point is at here. Okay, and now the moment, is anti-clockwise. Okay, suppose the point is, the force is at here. Suppose the force is at here. Okay, the force is at here and the point is at here. Now the moment is taking turn like this. Yeah, exactly. Anti-clockwise. And the perpendicular distance will be this. And the perpendicular distance will be this. Okay? The force is at here, the point is at here, and the perpendicular distance is at here. Okay? Okay? Okay. Now, any doubt about the topic? Moment? Okay. Okay, now we will discuss something about the some, let's say, 1 to 2 questions. Okay? Okay. Just a minute. Wait a while. Yeah. Let me try to solve a question. Okay? And in the question there will be number of forces. Okay, and you have to find out a moment at a particular point. Suppose the point is at here. Okay, this one is point where you have to take the moment. Clear? Okay, and the moments are applying at here, at here. This one is at here, this one is at here. Okay, is it okay to you? Is it visible to you? Okay, this one is 20 kilonewton, This one is 10 kilonewton. This one is 20 kilonewton. This one is 20 kilonewton. And the distances are 2. Okay. This one is 1. This one is 1. This one is 1. Okay. All the distances are clear. All the distances are clear to you. This one, the point is at here. Okay. The point is at here. You have to calculate all the moments. Okay. By the individual forces. Okay. This one is 20 kilonewton. This one is 20 kilonewton. This one is 10 kilonewton. And this one is 20 kilonewton. Okay. Okay. Right now, we have to take this summation of moment. Okay. Summation of moment will be equal to moment by this, by this, by this, by this. Okay. This one will be 20 into 2. 20 into 2. Okay. 20 into force is perpendicular distance. Right now 20 into 2. Okay. And this one is turning clockwise. We are taking clockwise plus. Okay. Okay. 20 into 2. Next 20 into 1. 20 into 1, but in anti-clockwise direction. Is it clear to you? Anti-clockwise direction. Minus. Okay. Next, this one 10 into 1. 10 into 1. Because the point is at here. Point is at here. You are taking the distances from this point to the forces. No, no. It will not be 2 plus 1. Because the point is not at here. Point is at here. Okay. We are taking the moment at this point. Okay. So we have to take the distances from this point. Okay. 10 into 1. Clear? 10 into 1. And it is rotating like in this direction. Anti-clockwise. This will be also minus. Okay. And next, this one is 20. And right now, the perpendicular distance of this 20 will be 0. Why? Why? Exactly. Because this force is applying on the same line. The point is at here. The point is at here, and the force is also lying on the same plane. Okay. That's why it's not applying any perpendicular distance. It does not apply any perpendicular distance. Okay. Right now it's 20 into 0. Whatever it's plus or minus, it will not matter. Okay. So right now overall moment is 40 minus 20 minus 10. 40 minus 20 minus 10. Okay. It's overall 40 minus 30, that is 10 kilonewton meter. Okay. So the overall answer is the moment at this point is 10 kilonewton meter. In positive direction, it's in positive. That means clockwise. Okay. It's the moment at this point is 10 kilonewton meter clockwise. Okay. Clear? Any doubt related to the moment? Okay. Okay. Right now we will start next topic. Shall we move on next topic? Okay. So your next topic is beam. Okay. Sir, cooling दीजिए. Cooling. Wait, बेटा. First of all, the beam, it will contain three topics. It will contain three topics. The first one is different type of supports, different type of supports, different type of supports, as well as different type of loads, and after that, the overall the type of beam. Okay, very the important things you have to consider all the factor very clearly. The type of loading. Okay, have you read it before? Hello, have you read it before about the beam, about the support, about the loading? Yeah, in your classes. Okay. Is it clear to you or not? Okay. 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 Not an issue. Uh, First of all, thing is type of support. Okay. The first one thing is type of support. There are three kind of support. First one is roller. First one is roller support. Okay. This one is like this. This one is like this. Okay. And this and the FBD of this FBD, is it clear to you? FBD, free body diagram. Okay. Before that, we have to study some free body diagram also. Okay. So first of all, we will start FBD, free body diagram. Free body diagram is the depiction of forces on a particular body. Okay. Free body diagram is the depiction of forces on a particular body. Suppose this one is body. Okay. And it is lying on the surface. Clear? Okay. Right now, the weight of the body will work on downward. Okay. And the reaction from the surface to the body will apply on it like this. R. Take this one is ball. This one is body. The weight is applying downward direction towards the downward, and the reaction is applying towards the upward direction. Is it clear to you? Is it visible to you? Okay. Just suppose there is some another question. This one is a ball at an inclined plane. Okay. This one is inclined plane. Okay. 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 And in right now, hmm, sorry, your voice is not audible. What are you saying? Yeah, yeah, yeah. It's rolling, or you can say ki it's on the inclined plane. It's on inclined plane. Okay. The plane is inclined. Okay, and the ball is lying on this. Okay. So right now, the FBD of this plane will be like this. The weight, the weight is always applying on the downward direction. Okay, totally downward. W. Okay, because the weight is due to the gravity. That is W, which is mg. It is due to the gravity, and the reaction which is applying on it will depend on the surface contact. Okay, so it will work on this R. Okay, and right now it will this angle will matter on this angle theta. Okay, this angle will matter on this angle. Is it clear to you? The weight will the weight will apply on it like this, and the reaction will apply on it like this. Okay, like this. The thing you have to consider on the FBD is you have to consider the load which is applying on a particular body. Second thing is reaction. Third one is tension. If if on anybody it is applying. Okay, and the reactions. Okay, the varying type of forces which is applying on a particular body, which can be applied on a particular body. You have to consider all that things. Okay, you can't ignore anyone. Suppose this one is on this body, only a weight is applying on it and the reaction is applying on it. So you just have to consider only two forces. Okay, suppose this one is a this one is a body. The ball is attached with this string. This is a string. Okay, is it clear to you or not? Uh, the ball is attached with this string and the string is attached with this surface. Okay, and right now the reaction of this force, the FBD of this ball body will be like this. Reaction because the surface is attached with this ball on this point. So the reaction will apply on it like this. R. Okay, clear to you? Is it visible to you or not? Okay. The force is like this. The tension will be like this. T towards the joint of string where the string is attached. Okay, the string is attached with like this direction, and the string, and on the other end, it is attached with this ball. Okay, so this and the weight will always apply on the downward direction. W. Okay, 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 okay. So the FBD will be like this. Clear? Okay. Some another example. Some another example. Suppose this one is a ball, this one is the first ball, and this one is the second ball. Okay, and these are lying on the surface like this. Okay, so right now the ball one, ball two. The ball one FBD will be like this. W1, okay, downward direction. R1, the reaction. Okay, suppose this one is A, this one is B, this one is C, this one is D. The four contacting points A, B, C, D. So this reaction will be RA. This reaction will be RB. This one. Okay. And the main thing, the ball is attached with this ball also. Okay. So the ball one will exert a reaction on the ball two, as well as ball two will exert a reaction of the same amount on the ball one. Clear? Action reaction. Same, same, exactly same force, but in the opposite direction. Means ball one will react in this direction, and ball two will react in this direction with the same amount. With the same amount. Means R one two. Clear? On suppose we are applying the this one is like this. Ball R12 because right now B surface is exerting a reaction, A surface is exerting a reaction, weight of W1 as well as R12, or you can say R21. Okay, or you can do it R21 from 2 to 1. As well as right now on second body. It's R12. It's R12. Uh, this one is W2. 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 D. R D. Clear? R C. Okay. And the second was R12, RC, RD, and W2. And R12 is equal to R21 because the both ball will exert of the same amount of force in the opposite direction. But this will in the opposite direction. R21, R21 equal to R12. That, no. Opposite direction. Exactly. This is what R12 minus R21 equal to 0. That's why R12 equal to R21. The amount of both forces are the same. Okay. Uh, okay. Now we can practice some ball questions. I think this is also in your course. These are also in your course, na ball type of ball of questions. The free body diagram type of questions. First of all, which book you are following? Which book you are following? It's a Bhavakoti or someone else? Engineering. Why? Okay. 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 Right now, you have a question of like this. The ball is at here and the ball is at here. Is it clear to you? The question? Right now, it is contacting at A, at B. This is like this. Okay. B at C. Okay. This one is ball 1, this one is ball 2. Okay. Okay. And the angle of this direction is somewhere 60 degree. It is somewhat 60 degree. हाँ सर. Okay. Yeah. And right now, so FBD of ball 1. FBD of ball 1 will be like this. RA, RB. Okay. R21, R21. Okay. And W1. Okay. Okay. And on the other hand, ball 2, FBD of this it will be RC, W2 and R12. Okay. Okay. I think no other force will applying on it more than this. This one contains this, this and weight. And this one will contain this and this. Three forces. Okay. Suppose we are given W1 equal to 1000 kilonewton. Okay. We are given W1 equal to 1000 kilonewton and W2 equal to 800 kilonewton. Okay. Okay. Now we have to calculate all the reaction forces. We have to calculate all the reaction forces. Okay. So in this diagram, we are just given two things, W1 and W2. And the third thing is angle, 60 degree. Nothing else. Okay. So when we have to calculate this portion, we have three unknown things and only one known thing. Clear? And in this diagram, you have one known and two unknown. Okay, so it will be far better for us to solve it. Okay, and right now we will take first of all ball 2. Okay,